Question 6c. The graphs of the curves y equals x squared and y equals 12 minus 2x squared are shown in the diagram. Part 1. Find the points of intersection of the two curves. The points of intersection of the two curves are found by solving simultaneously the equations y equals x squared and y equals 12 minus 2x squared. So we can substitute x squared for y in the second equation. So we have x squared is equal to 12 minus 2x squared. Adding 2x squared to both sides of the equation, we have 3x squared is equal to 12. Dividing both sides of the equation by 3, we have x squared is equal to 4. And then taking the square root of both sides, we have x is equal to plus or minus 2. Now using this equation here to determine the y value, when x is negative 2 or positive 2, squaring it will give y equals 4. So therefore, the points of intersection are negative 2, 4 and 2, 4. Part 2. The shaded region between the curves and the y-axis is rotated about the y-axis. By splitting the shaded region into two parts, or otherwise, find the volume of the solid formed. The solid is formed by rotation of the curves about the y-axis. Hence the volume V is given by the formula V is equal to pi times the integral from y equals y1 to y equals y2 of x squared dy. The strategy is to split the region to be rotated into two parts, A1 and A2. There's a common boundary between the two regions, which is the line y equals 4. And this comes from the point of intersection that was found in part 1. And because we're integrating with respect to the y-axis, y equals 4 is the common boundary. So we don't use this value here. Now we're going to rotate regions A1 and A2 separately and add the resulting volumes. So for region A1, we have y equals x squared, hence x squared is equal to y. And the volume is pi times the integral from y equals 0 to y equals 4 of y dy. And for region A2, y is equal to 12 minus 2x squared. We need to make x squared the subject. So x squared is equal to half times 12 minus y. And the volume is equal to pi times the integral from y equals 4 to y equals 12 of half times 12 minus y dy. Now volume 1 plus volume 2 is equal to pi times y squared over 2 from y equals 0 to y equals 4 plus pi over 2 times 12y minus y squared over 2 from y equals 4 to y equals 12. Applying the limits of integration, that equals pi times 4 squared over 2 minus 0 plus pi over 2 times 12 minus 12 squared over 2 in brackets minus 12 times 4 minus 4 squared over 2, which equals 8 pi plus pi over 2 times 32, which equals 8 pi plus 16 pi. Therefore, the volume is 24 pi cubic units.